Hello friends, so let's talk about the variation in the measurement system analysis. Companies like the PCBI Pro use a measurement system to evaluate paths relative to specifications. In here, the engineer uses the PCBI viewer measurement tool to measure distances between components on circuit boards. The amount of variation that is acceptable in their measurement in their system depends on their specifications. So how can we compare different sources of measurement variation in PCBA Pro's measurement system relative to their specifications? Okay, so we can incorporate tolerance into our gauge and study in statistical software. Recall that tolerance is the distance between the upper and lower specification limits. Suppose PCBI Pro set their tolerance at uh, 0.2 mm, 0.2 mm. So if the true distance between components is 5 mm, then the lower specification limit for the part is 4.9 mm and the upper specification limit is 5.1 mm. So is the PCBA viewer measurement tool is good enough for us to use for accepting or rejecting parts? To answer this question, so let's look at the output when tolerance is incorporated into gauge and study. The percent tolerance column shows the different sources of variation of measurement variation compared to the tolerance. mm, tolerance. So ideally, the percentage of tolerance for the total gauge INR would be close to zero. So meaning the variation due to the measurement system is small relative to the tolerance. So let's look more closely at the PCBI viewer measurement tool system and see if it meets the acceptable tolerance for PCBI Pro. So suppose the true distance between components on this circuit board is 5 mm. So because the distance is exactly on target, so the board meets specification. So assume that the PCBI viewer measurement tool is accurate. That is, the measure distance should be within specification 99.73% of the time. Based on the gauge INR output, the total gauge INR study variation, the total gauge INR study variation for the PCBI viewer measurement tool is about 0.096. We calculate the percentage of tolerance by dividing the study variation by the tolerance and multiplying this value by 100. So this gives us the result is 47.98%. We already know that this boat missed specification because its distance is exactly equal to the target of 5 mm. Of course, not all parts are made exactly to the target due to variation in the manufacturing process. So if the true distance between components on this board falls within the acceptable range of value, then the board meets specifications. So how does a percent tolerance of 47.98 affect our ability to distinguish between both that meet specification and both that don't? To illustrate, consider a boat with a true distance of 5.08 mm. Recall that the tolerance is set at 0.2 mm. Tolerance is set at 0.2 mm with an upper specification limit of 5.1 and a lower specification limit of 4.9. So does this boat meet PCBA Pro specifications? The answer is that the true distance is uh, within the specification limits. Okay, so this boat meets PCBI Pro specifications. So how about this boat? According to our measurement, so does the circuit board meet PCBI Pro's specification? So we see here this the measure value is greater than upper spec limit. So the board does not meet specifications. So even though the board's true distance is within the specification, the measure value suggests otherwise. So why did this occur? With a percent tolerance of 47.98%, there is a chance that the PCBI viewer measurement tool will measure an in-spec board as out of spec. A variation that is 47.8 47.98% 98% of the tolerance is usually considered very large. Recall that various industry and professional organizations, such as the Automotive Industry Action Group (AIAG), provide guidelines that can help us determine whether this level of variation is acceptable. These are the same standards we use for percent of study variation. So let's review. Tolerance is the difference between the upper and lower specification limits for the parts being produced. It might be useful to compare the different sources of measurement variation to the tolerance of the process. Thank you for listening. In the next lesson, we'll talk about the process variation.